In this example, we're going to talk about 3 hoses. They fill 3 different water barrels. Now, a green hose fills a water barrel at a constant rate. A black hose is slowly opening when filling the barrel, and a blue hose is completely open at the beginning and then slowly closed. The 3 graphs of the situation are shown. So in this first graph, what's happening initially? Well, initially, our water level, the number of gallons we have, is not increasing very quickly. And then it increases very quickly. So I'm going to demonstrate this for you by showing you between time is 0 and then whatever this value is right here. Whatever that value is right there, there hasn't been a lot of change. In fact, there's been very little. However, in that small amount of change in red, there's been a large difference in the number of gallons. Let's look at graph C. So in graph C, what's happening is there's a large difference initially, and then it begins to fill slowly. So let's look at that. Initially, from time equals 0 to about time equals whatever that value is right there, we've got a very significant change in the number of gallons in the bucket or in the barrel. And then from this time all the way to the end, which is a larger amount of time, you can see that the number of gallons in the bucket is significantly less. That increase slows down significantly. So in one case, we're filling up slowly and then quickly, and then the other one we're filling up very quickly and then very, very slowly. So let's look at, since I've used highlighters, which one fills up quickly and then slowly. The green hose fills a water barrel at a constant rate. Well, that's not quickly and then slowly. A black hose is slowly opened when filling the barrel, and a blue hose is completely open at the beginning and then slowly closed. Well, that's the one that's going to fill up quickly in the beginning and then slowly at the end. The one that's going to fill up slowly and then quickly is the black hose. And the green hose is going to be at a constant rate, which is what we see in the middle. So let's write those down. So this first one is the black hose. The one in the middle is the green hose. And the last one is the blue hose. And that answers our question for A. Now let's see what our questions are for B. So when we go to the next page, it says, describe the water level represented by each graph. Let me go back quickly here. Black, green, and blue. I'm just going to rewrite that. This is the black hose. This is the green hose. And this is the blue hose. Describe the water level for A. Well, graph A, the water level changes slowly. It increases slowly. I'm going to change that to increases. So it increases slowly. Then very quickly. For C, it increases quickly. And then slowly. And then the next question just asks us which hose is which. And that's how you read a graph. Here's one for you to try, so please press pause And when you come back, I'll reveal the answer. So welcome back. Graph A pitched the ball like a pitcher. And the catcher dropped the ball. And it landed in the ground. And then it just stayed there because the catcher was embarrassed. The second one in the middle, this looks like two people maybe playing catch where the ball never hits the ground. And the third one looks like a ball got thrown and maybe got stuck in a tree. Now, number 3, if you answered these questions, number 3 would be graph C. And describe the height of the ball represented by the other two graphs. We've already done that. Now I'm going to finish up this lesson by talking about continuous graphs and discrete graphs. Continuous graphs is when all the points are connected. This is a very important concept. A continuous graph is when all the points are connected. In each one of the cases that we had continuous graphs. And that's because the horizontal axis stood for time. And time continued, the clock continued to tick, time continued to pass, regardless of what was happening. And we weren't taking measurements at certain intervals. So all the previous examples were continuous graphs. A discrete graph is when the points are not connected. So your points on the graph are not connected. And connecting them, in fact, would not make any sense. Connecting the points would not make sense. Now it's important for us to remember, since we're going to be talking about graphs here, it's important for us to remember that we have an x and a y-axis. The x-axis is the independent variable, and the y-axis is the dependent variable. So if I put that in an ordered pair, independent variable, which is your x, comma, your dependent variable, which is y. So a discrete graph is when the points are not connected. Your independent variable is not continuous. So it doesn't make sense that you would connect the dots. And I'll show you a really good example that's going to make that pretty clear for you. Here we have a student taking a test. So you've got the number of problems correct along your independent axis. So here's our independent axis in yellow. And those are the number of problems correct. And then along our vertical axis, we have the number of points. This is called a discrete graph because the number of problems that you get correct is not continuous. I can't have 0.7895 parts of a problem correct. Okay, the problem is either correct or incorrect. So the number of problems correct and the number of points varying depending on that. So the number of points depends on how many problems you get correct. A student is taking a test. There are 10 problems on the test. For each problem the student answers correctly, the student received 10 points. This graph is made up of multiple unconnected points, so the graph is discrete. This is important. It's made up of multiple unconnected points, therefore the graph is discrete. You can answer anywhere from 0 to 10 questions right, so the domain is the whole numbers from 0 to 10. So how we write our domain is going to be written as a set of numbers: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that's how we would write our domain. The range is not continuous either. The range, you could get 0 points, 10 points, 20 points, 30 points, 40, 50, 60, 70. Somehow I went right back to where I was. I don't know how that happened. Let's erase this. 70, 80, 90, or 100. So that would be our range. So our domain and our range. Now, what does a continuous graph look like? Well, a continuous graph could be modeled by a bathtub being filled with water. So after 10 minutes, there are 75 quarts of water in the tub. So we start at time equaling 0 with no water in the bathtub, and then 10 minutes later, we have 75 quarts of water in the tub. So it could look something like that. Then someone accidentally pulls the drain plug while the water is still running and the tub begins to empty. The tub loses 15 quarts in 5 minutes. So 5 minutes after 10 minutes would be 15 minutes, and we lose 15 quarts, which brings us down to 60. Whoops, I'm struggling here. There's the line. We'll just make the line in black. There we go. Then someone plugs the drain and the tub fills for 6 more minutes. So 6 more minutes. So 15 to 21. So I'm going to put a 21 there. And it fills up, so it's going to get higher. And it gains another 45 quarts. So 45 quarts. 90, 45 would be right there. So we're at 105 quarts. After a 15-minute bath, so 21-minute mark plus 15 is 36 minutes later. So, or from the time that we started filling it initially. So after a 15-minute bath, the person gets out and pulls the plug. So 21 plus 15 is 36. So at the 36-minute mark, they had been sitting in there with no change in the level of water. But then they pull the plug, and it takes 11 minutes to completely drain. So 36 plus 11 is 47. And it takes that long to drain. Now, because as you were filling up the tank or the tub, the number of minutes was continuous, the time kept going on the clock, your domain is continuous, and the water level was continuous. So this is called a continuous graph. And the domain goes from 0, so this is our domain. We start at 0 time, so 0 minutes, and it goes all the way to 47 minutes. 0 minutes is included, so that's a bracket, 0. 47 minutes is included, so that's a bracket. So our domain goes from 0 to 47, and it's continuous all the way. The range goes from 0, and it continues all the way up to 105. And it is also continuous. Before, when we first got in the tub, there were 0, so 0 was included, 0 quarts. And when we were in the tub and we reached the maximum number of quarts, it was 105, which was included, and that is a bracket. And that's how we write our domain and our range. Remember that your domain are all of your x values of your independent variable, and your range are all of your y values of your dependent variable.